Hello, geometry students. Welcome to Chapter 11. Chapter 11 is area. Some of these formulas may feel very familiar to you, and especially at the beginning. Notice Section 11.1 is areas of parallelograms and triangles. We've talked before about parallelograms, just in case you need a quick refresher. A parallelogram is a quadrilateral, so a four-sided figure in which opposite sides are both parallel and congruent. So if I were to draw it, it would look something like this. And if you don't believe me that the opposite sides are parallel, whoops, let me try that again. Opposite sides are parallel. I could put my parallel arrows and my doubles over here. If you didn't believe me that my opposite sides are congruent, I could put congruent dashes on the top and bottom, congruent dashes double on the sides. Now you have to believe me, even though I'm not a very good parallelogram drawer. So you probably already know the formula for the area of a parallelogram. It's area, capital A, equals base times height. Notice the B and the H are both small letters. That does make a difference as we go through this chapter. Capital letters in math are things that we have to do work for. Small letters in math are things that are usually given on a diagram. So the base and the height, this is why I don't like to use length times width, because in a parallelogram, our length and our width are kind of messed up, right? The base is typically our bottom, we usually think of base as the bottom. The height has to be perpendicular. So usually they'll draw a little perpendicular dotted line, and that would be the height. Just like when you get measured at a doctor's office, they tell you to stand up straight, not all crooked. That has to be perpendicular. So make yourself a note. You'll often have these little ghost triangles in here denoting what the height is. Our units of area is always squared. So it might be the area is 25 meters squared or 38.2 inches squared. And I just mentioned this, the height is always perpendicular to each base. It'll be a right angle. We usually just mark it on the one side, but technically this guy up here is perpendicular as well. Because the lines are parallel, that goes back to an oldie but a goodie. Everybody knows the perpendicular symbol, right? Upside down capital T means perpendicular. If you don't know that, didn't learn that a while ago, you should definitely know it. So right angles. All right, so quick problem here. I don't think it should take too long. Find the area of parallelogram EFGH. Area equals base times height. Sometimes I'll even give you like, oh, well, this is 22 meters. Just to let you know that you can have extra information that you ignore. If the formula for area of a parallelogram is base times height, it's pretty obvious that that 22 that I added on there is really nothing. It's a slanted side. We could use that for other purposes. We're going to throw in some trig / SOHCAHTOA, maybe some Pythag, different things in that you might need to do. But if we're looking at base times height, the base is the bottom, 30 meters, times the height is 18 meters tall. That gives us an area of something like 540. If we were putting a label on there, because everything else is in meters, it would be meters squared. Easy peasy, right? Base times height. So let's talk about a triangle. We all know what a triangle is. It looks a lot like parallelograms. It is base times height all over 2. We know that the B stands for base, the H stands for height. I also rewrote this. The area is always units squared. We know, just like anything else, it doesn't matter. I could give you a nice, neat right triangle, right? I could tell you the base is 12 and this height is, I don't know, 16. You could figure out the area. But I could also give you more of a obtuse triangle. So I might have to add in that ghost triangle that looks like this. This would be a right angle right here. So maybe I tell you that the bottom part of this triangle is 27, and I tell you that this is 19. So that's technically telling you the base times the height, or the base and the height. I wanted to mention that because height always has to be perpendicular. We need that right angle box in there. So sometimes, again, you'll have a ghost triangle because it tells us what that height is. And I think I had one more thing on there. And you already all know, don't you, that the perimeter is equal to the sum of the sides. These problems are going to say, here's a triangle, find the perimeter and the area. If I look at that top right triangle that I made, I could easily find the area by doing base times height. But if I wanted to find the perimeter, I would need to find this side right here. So make yourself a little note. You may need to use Pythag. If I did the Pythagorean theorem on that top problem, 16 squared plus 12 squared equals x squared, I could figure out what that hypotenuse is, and then I'd have 3 sides to add up to find the perimeter. This other one is a little trickier. This obtuse one, I'd have to give you more information. So, quick example. Find the perimeter in the area. Notice the ghost triangle on this one. So, I don't know, let's start with perimeter. That seems easy. Sum of the sides, right? I'm not including that 9 because that 9 is not actually a side of the triangle. I'm going to add up the 3 sides that are shaded in blue, 16 plus 12 plus 7.5. So my perimeter is going to equal something like, oh gosh, 35.5. And it doesn't have labels on it. I'm just going to say that it's 35.5 units, whatever those units are, right? They could be inches or centimeters or whatever. When I go to the area, which I know the formula is base times height, all over 2. Some people like 1/2 times base times height. This one works better for me. If you want to do it the other way, you're welcome to. So the base, remember the base and the height are always perpendicular to each other. The base is perpendicular to the height. So look for those sides. Sometimes you might have to turn your paper sideways. That's all right. You can still find the base and the height. So this 12 is going to be the base and the 9 is going to be the height. So 12 times 9, don't forget to divide by 2 at the end. So the area for this particular triangle is going to be something like 54. If we were putting a label on it, we don't know, so I'm going to say units squared. Could be 54 centimeters squared, miles squared, whatever it might be. All right, now you know how we just jotted down that you could use Pythag? Here, we may need to use SOHCAHTOA. It's a long one to write. So it says to find the area and the perimeter of this quadrilateral RSTU. I feel like we can easily find the perimeter, right? Add up all 4 sides. One of the rules that we know is opposite sides are congruent. So if I'm going to add up all 4 sides, I've got 2 sides that are both 32 and 2 sides that are both 24. You can type that into your calculator however you like, but I believe the perimeter is going to come out to something like 112 inches. The area is base times height. Well, the base is pretty easy, wouldn't you agree? That's 32. I see a line that's perpendicular. If I could figure out this line, I could know what my height is going to be. I'm going to put an H on that height. And then I'm going to look at this diagram. Let's see, we said that this side over here, ST, was 24. They give us this angle here is 30, and I want to know H. I'm going to take this triangle out for just a second. So here's S. Here's that dotted line here that I labeled H. Here's that right angle. I'll mark it on the other side. Here's T. This is 24, and this angle right here is 30 degrees. So I could do SOHCAHTOA. I call this side work. We do quite a bit of side work in this chapter. So the side work is figuring out what the H is, right? We don't know H, But if I'm thinking about this angle S, this 30-degree angle is my angle. It's a right triangle. The 24 is my hypotenuse. Side H is not opposite, so it's adjacent. So what are we going to do for adjacent over hypotenuse? Looks like a cosine problem to me. So we're going to do a quick cosine of 30 degrees equals adjacent over the length of the hypotenuse. If you prefer an x in there, feel free to use an x. You can use whatever variable makes you happy. I use an h because it reminds me that that's what I'm finding. So I'm going to multiply both sides by 24. So when I go to my calculator, I'm going to figure out h by typing in 24 times the cosine of 30. I'm going to always go out 2 numbers after the decimal. Make yourself a note. And I'm going to say it's a 20.78 when I type that in. If you got something different, let me know. It's probably a calculator setup issue. So the height that we just found with our side work was 20.78. So now I can finish this problem. 32 times 20.78 gets me an area of something right around 664.96. If I'm going to put my units on there, it's going to be inches squared. So it's all formula work, but it's those darn side problems, right? So just be watching out for those. You can throw in a Pythag, you can throw in a SOHCAHTOA if you need to take out a triangle to write it so you can see it separately. Do that. All right, let's see what else we got here. This is an easy section, isn't it? So example 4, the Warners are planning to recarpet part of their first floor of their house. Part of it. Not all of it, right? If it was all of it, we could just do a big old base times height. Find the amount of carpeting needed to cover the living room, the den, and the hallway. So I need those 3 pieces. So hopefully you see, first of all, we might need to know this guy right here. That might be helpful. We could find all 3 areas and add them together. I'll just say add separate areas. So for example, the area of the den is equal to base times height, so that's going to be 15 times 9. The area of the living room, I'll put LR, is going to be equal to 15 times 13. The area of the hall, this one's an interesting one. I know that it's 13 feet tall, but what about the width? Well, if I go up here, the whole width of the house is 35, right? This is 15, this is 15, so I believe there's going to be 5 feet left for that hallway. So that's going to be 5 times the 13. I get all 3 of those separate areas, add them all up, and I know how much carpeting the Warners are going to have to buy. So look for those little sneaky problems. And then we throw in this one, which is even better. We'll just do the first one. So part A, it says to find the area of each shaded region. It's like a rectangular donut, right? Would you agree that I'm taking rectangle ABCD out of WXYZ in example 5A? Well, take out is actually literally a math clue. What are you going to do if you're taking something out or taking it away? We're going to subtract. So we're going to find the area of WXYZ, and we're going to subtract the area of ABCD because we're taking the little area away from the larger one. We're popping that right out of there. So this doesn't seem that bad. The area of WXYZ, base times height, looks to me like it's a 32 base times a 16 height. Area of ABCD, the base is 12 and the height is 5. I'm going to just do these 2 pieces separately. So what's that end up being? 512 for the area of the larger, minus 60 for the area of the smaller that we're taking away. So our area of the shaded region is going to be something like, I'll put area of the shaded equals 452. And if I were being technical and putting units on it, it would be centimeters squared. The last example is an interesting one because there's a lot of different ways to see this. So I personally see splitting it up this way. I could do a little rectangle on top, a medium, and then a bottom one, add all the areas. But some people might do a tall rectangle, a middle, and a short rectangle. You could do a bunch of different things depending on how you see it. As long as you show your work, you will get the right answer, and you do your math right, you will get the right answer. Let's leave that last problem for class. Otherwise, that is it for section 11.1. Thanks for hanging around, and I will see you next time.